For problems 7 through 12, this is going to review unit 3.2 when we had to multiply and divide, but then, of course, talk about excluded values as well. So I'm going to do 8 and then 9. So 8, because these two fractions are multiplying, remember when you multiply straight across. But I'm not going to actually multiply yet because there is some simplifying I can do. Because they're held together by multiplication, I can divide out pieces because it's technically multiplying, right? So I can then divide because multiplication and division, because they have similar properties, we're good to go, okay? All right, so the 6's I can cancel out, they go to 1. And then what I'm going to do is I'm going to factor. So I'm going to think what multiplies to give me positive 18 but adds to give me negative 11. So I'll have n minus 2, n minus 9. And then over here on the left, I'm going to have to do GCF factoring. And I'm going to get 2n times n minus 9. So then the n minus 9 divides out, and I have n minus 2 over 2n. All right, so that's a minus. So that's the simplified version of the multiplication, but I'm going to now analyze the excluded values. So here and here. Now 6 can't become 0 on its own, so I don't have to worry about 6. But I do have to worry about the 2n and the n minus 1. So I got, and they're multiplying, so I got to figure out how each factor can become 0. So if it helps you, you can set it equal to 0 and solve. If you can look at it and see, great. So to solve this one, I'm going to divide by 2. So 0 divided by 2 is 0. So n cannot be 0, and n cannot be 9. Those are my excluded values there. Okay, I'll do 10 actually. No, I'll do 9. Yeah, I'll do 9. Okay, so the excluded values happen because you cannot divide by 0. So when you see 5b to the 4th divided by 8b to the 3rd, remember this means divide. So I got to make sure that this does not become 0. But notice the first fraction is getting divided by the second fraction. So this is a rare case whenever you divide. It's a rare case when you got to make sure that this does not become 0, because that's dividing by 0, but also this does not become 0 and this. So the only one you don't have to check is the original numerator. Now, don't overgeneralize this rule, okay? Like on 7, you're only going to check the denominators because it's multiplying. You cannot divide by 0, and so because of this division, it makes you check this numerator. So just keep that in mind. All right, so first, because they're held together by multiplication, 10b cannot be 0, and 8b cubed cannot be 0 as well. So if you solve those, you're going to find out that b cannot be 0. No matter how many b's there are, just through multiplication, 8 times 0 is the only way to make it 0 when it's held together by multiplication. So there's my excluded value. So what I'm going to do first is I'm actually going to notice that there are, before I even do anything with division, I'm going to notice that I have 5 times b times b times b times b over 8 times b times b times b. And they're held together by multiplication, so I can divide those out. So the first fraction I'm left with 5b over 8 divided by 10b over 5. Now with division, you got to remember 5b over 8, so keep, change, flip, or multiply by the reciprocal, whatever helps you remember. Yeah, that's great. Okay, so I'm going to cancel out the b's, and then I'm going to rewrite the 10 as 2 times 5, and notice I can cancel out the 5's. So then the only thing I'm left with in the numerator is 5, and in the denominator 8. So 5/8 with the excluded value of 0.